So I just did that video where I solved a problem of where finding the work done by a bunch of different forces on an inclined plane. And the last part of it, well actually the third part of it, was finding the work done by the force of gravity. And I showed you two different ways to do that, and it occurred to me that I'd like to sort of focus on that and draw it a little less cluttered so that you could really see the two different ways that I did it. And then that way maybe you could choose which one you thought made the most sense to you, because both ways are equally right, and it's just a matter of which one makes the most sense is the one that you should be working with. So in the first part, when we find the work done by gravity, I was approaching it in a very straightforward manner where I did just, in a way, it's almost like a plug and chug, where I think about what's the force. Okay, the force is mg. The displacement is up the incline, and so that's my s. And the only tricky part about this was, what is the angle? The angle is between the displacement and the gravity. And so if we think about the displacement being right here, we can visualize it there. Then this is the angle that we're interested in, that goes all the way from the positive x-axis down to where gravity acts. And so that ends up to be the cosine of 90 plus theta. And because this is going to be a negative answer, my work done by gravity is going to be negative as well. Now, another way to approach this, as I said, is to think about, one way you can think about it is that you're looking at the component of the displacement, that the part of the displacement that's parallel to the force. But another way we could think of it is by writing in unit vectors in terms of what the displacement might look like. And so, for instance, we can really embrace the idea that this force is a dot product. And so we could write the forces and the displacement in terms of unit vectors. Now, gravity acts downward, and I'm just going to, for now, I'm going to sort of use a more traditional setup for the axes, because this can also work without an inclined plane, so that my force, which is the force of gravity, is in the negative y direction. Now the displacement then in this case would be, it would have an x component and a y component. So in a sense, as the block is moving up the incline by this displacement, I'm going to just get rid of this s right here. We could think of this as the delta y, and that is the delta x. And so adding the delta x in the x direction and the delta y in the y direction ends up giving me the total vector s. Now, when I'm doing this, the j dot I, that term is 0, and then I just have minus mg, j dot j is just 1, times my delta y. And my delta y, I'm going to, right here, could be written as s times the sine of the angle. So this could end up to be minus mg, and then the way that I would find the displacement in the y direction would be the displacement, which is really the hypotenuse, times the sine of 30. And again, negative work done. You might not really be sure of it, but I put 30, but right here I hadn't really designated my angle, and so let's make it just theta. You might not be familiar with it, but there is a relationship between the cosine of 90 plus theta and the sine of theta. It makes both of these terms actually end up to give you the exact same numerical value. But it's sort of two different ways to think about how I would calculate the work done by gravity, and I wanted to show you both of those without all the clutter of all the other writing for the other parts of the problem, and also for the diagrams to be less cluttered. So hopefully that's helpful.